Hi, my name is Shaelynn and I teach physics at Sunway College, Johor Bahru. You might think that physics is for the weird, nerdy Einstein brainer out there. But today, I will show you that physics is for everyone and it can happen at anywhere, even in the most uncanny of places, like the kitchen top. Come!
This is Miss Physics. She is going to peel 2 boiled eggs for breakfast. Oops! It's a raw egg. Shouldn't it be boiled? Isn't this one of those messy moments that any one of us can encounter? To avoid this, we can do a simple experiment. These are 2 eggs, one boiled and one raw. We will now spin the eggs quickly. If we try to stop the raw egg, it will continue to spin. But if we try to stop the boiled egg, it will stop immediately. Why does this happen? When we stop the boiled egg, we stop the entire egg because this is a solid object. But when we stop the raw egg, we only stop the shell of the egg. The liquid inside continues to spin because nothing has made it stop. The liquid then pushes the shell forward and the egg continues to spin.
This is due to the law of conservation of angular momentum. That means if something is spinning, it will continue to spin until something stops it. The most interesting thing is that the physics that we find in the spinning raw egg can be applied to spinning ballerinas and even bigger things like the Hubble telescope that take pictures of the universe. Yay! Now, Miss Physics is so disappointed as she wasn't able to eat her hard-boiled eggs this morning. She's now looking forward to her morning coffee. Wow! 2 cups of coffee for me. Yes! This is not coffee!
If we rewind the situation, we can differentiate coffee from other beverages by looking at the stains that they make.
Coffee leaves a stain like this after drying, and this ring is more commonly known as the coffee ring effect. Why and how does this happen?
The answer lies in the shape of coffee particles and how evaporation happens. This is a drop of coffee with coffee particles in it. When a drop of coffee is on the surface of the kitchen top, the rate of evaporation at the end of the drop is quicker than the rate of evaporation from the middle of the drop. Since coffee particles are spherical in nature, it can easily detach from the interface and it flows past one another. Thus, when the liquid in the middle flows outward to replenish the evaporated edges, coffee particles are being carried together with the outflow and collects at the edge. When it dries completely, the coffee particles have now collected at the side of the drop, leaving a ring-like stain.
Knowing why the coffee ring effect happens is not just for Miss Physics. In fact, it has great industrial applications. For example, when we're making paint or doing colored painting, we do not want the coffee ring effect in our end product. So what do? The answer is to change the particles from spherical to ellipsoid.
Ellipsoids experience strong attractions to other ellipsoids in an interface, causing clusters of ellipsoids to form. Thus, as the liquid in the middle flows outward to the edges, the clusters of particles increasingly block each other, creating a traffic jam of particles that eventually covers the drop's surface. This will leave a stain without the coffee ring effect. Knowing the physics behind boiled eggs and coffee rings, Miss Physics is now much cleverer. Every morning, she will spin her eggs and check for coffee stains. From this, we can see that physics is not a subject for the weird people, but for me. I will now leave you to the side of Miss Physics enjoying her cup of hot coffee and her boiled eggs. I hope you have enjoyed today's fun session. See you again at Sunway College, Johor Bahru.